Hi. So here we're going to look at geometric sequences, and a geometric sequence is one where there is a common ratio between the terms. So for example, common ratio is equal to u3 divided by u2, which is equal to u4 divided by u3, which is equal to u5 divided by u4, and so on. An example of that would be 1/2, 1/4, 1/8, 1/16, continuing, where the common ratio between them is a half. And then we could also have an algebraic geometric sequence, such as x squared, x cubed. The common ratio there is x. Now, one of these formulas you're given, one of them you're not. If you want to find the nth term, or un, you can get that by a, the common ratio, the first term, times r, the common ratio, to the power n minus 1. But if you want the sum formula, which you are given in the exam, s of n equals a bracket 1 minus r to the power of n over 1 minus r. Now, straightforward enough for most parts, however it can get a bit confusing, and there needs to be some algebraic manipulation when it comes to more complicated ones. So, find an expression for un of the sequence 4, 8, 16 if you do example 1. So the first thing is, I already know what a is, it's 4. And now I just need the common ratio. So it's that straightforward. 4 times 2 to the power n minus 1 will give me the nth term. Now I need to find the formula for the sum. So I've simplified that as far as possible, or as far as I wanted to actually. So it becomes -4 times 1 minus 2 to the power of n, and now all we need to do is sub in 15. So it comes out as 131,068. Now what have we not got enough information? I need to find un given that u3 equals 48 and u8 equals 49,152. Well, let's work with what we got. Now using a little bit of algebraic manipulation, I can rearrange that to just be, so let's take the u8 and divide it by u3. The a's cancelled out, the r to the power 7 over r squared becomes r to the power 5. 49,152 divided by 48 is 1,024, and then r equals 4. Now all I need to do is calculate a. Gives me a equal to 3 by substituting an r into any of the equations that we've got from the first half of the question, and then I can just state un. Three times 4 to the power n minus 1. So, a slightly more complicated question to do with sums. For the sequence 4, 6, 9, carried on, what is the smallest value of n such that the sum is greater than 200? Okay, so let's first of all get an expression for the sum. So I've got the a first term being 4 and the common ratio being 3 over 2. 2, s of n equal to negative 8 times 1 minus 3 over 2 to the power n. Now I want that to be greater than 200. So what you're about to watch is me make a mathematical mistake at the board. I know, I can't believe it, I never make them. That's correct. And now I've decided to, instead of dividing by negative 8, I've decided to add 8, leading to an incorrect answer. That should be negative 25 on the right hand side. But what I'm going to do is explain that the method is still correct, but with the wrong numbers. So what am I now going to do here? I've got power. Now what's the opposite of power? It's a logarithm. So if I take the logarithm of 3 over 2, base 3 over 2, I can eliminate that and get the answer. That was me confidently explaining what I was doing incorrectly. However, the method, like I said, is correct. I've just done the first line incorrect, but at the end of the video I'll cut to something which shows you with the correct numbers. And now we can just put that into our calculator and calculate what n is. Oh, he's such a confident idiot. Starting to get a bit confused. I even check the answer in the textbook, decide to ignore it. N has come out as 13.152. What is the smallest value of n such that s of n is greater than 200? Well, at n equal to 13, it is not greater than 200. So the first value of n that is greater than 200 must be 14. Fully committed to my mistake. Keep going. So it can be fairly straightforward with sequences and geometric sequences, but it can very quickly turn into complicated algebra, including even at logarithms, because we have to deal with the exponentials. But that's hopefully explained what geometric sequences are. So here I've fixed my mistake. I've started with negative 8 bracket 1 minus 3 over 2 to the power of n is greater than 200, leading to 1 minus 3 over 2 to the power of n is greater than negative 25 because I've divided by the negative 8, not added it. Then I can rearrange that for 3 over 2 to the power of n is greater than 26. Taking the log to the base 3 over 2 leads to n is greater than log to the base 3 over 2 of 26. And then that leads to n is greater than 8.0354, which leads to n equals 9 as the smallest value of n that allows the sum to be greater than 200. Okay?